exam for this class on Monday. Tuesday. This is exam 2 for this is on Tuesday. Yeah, Tuesday. Okay, subatomic particle negative.
Electron.
Electron. What factor determines a suitable conductor? It's always the same thing. Conductors and insulators are determined by the number of
Valence.
electrons in the valence shell. I have that register now.
You gotta sign up for this thing. It's gonna get you every time.
Cancel.
Yeah.
Abort.
I should
It says
complain.
you click on the never show again button.
Oh, did it say?
Yeah. We're all
They deprive me of that? Okay. The number of electrons in the valence shell. And so and I'll remind you that the fewer electrons, the better the conductor. The more electrons, the better the insulator. A semiconductor will be somewhere in between. And a resistor is a semiconductor. We don't want full flow, and we don't want full restriction. We want to regulate it. Give an example of a good conductor. It could be copper, gold, silver, aluminum. What unit of measure describes current? Amp. Everybody's got 100% so far. Okay, and so
Take it now.
show so many ohms in metric notation. Remember, I'm still getting problems with this. If it says metric notation, I want to see mega, milli, nano, pico, something. In metric notation, there are powers of 10 and multiples of 3. So I still want to see between 1 and 999. I want to see a number to the left of the decimal. I got a couple where you gave me a point and a number. It's got to have numbers to the left of the decimal. No more than 3. Okay, so so many number of amperes in mechanical metric notation. I'm tongue-tied. So again, milli, micro, nano, pico, something like that. What is the color code for so many K and so much percentage? So you give me 4 colors for that one. Then we'll give you 4 colors and you'll convert it back the other way. Tell me how many ohms the resistor is. What are the possible min and maximum? So you'll take, if it's 5%, you'll figure out 5% from the previous.
5% times the number. Right?
And you add it and subtract it. I like to see the range. I would like to see you add it and subtract it in. And then you get a series circuit, but they're not all ohms. So like I said, 1 ohms gap current. It's a series circuit, so current is going to be the same all the way down. So you get current in any of these positions, you've got current for all of them. Then you've got watts, voltage. So out of 4 lines, you have 2 units, 2 pieces of information in all of them, but 1. 3 out of 1, 3 to 1, 3 out of 4. So if you do that, it's series, the voltage and the resistance add up. So if you've got everything but missing 1, all you have to do is figure the difference. Just like this one. If this were a series circuit, I'm missing the voltage for R2. R1 and R2 and R3 add up to the total. So I just figure what, subtract it from the total, and there's my missing value. I can do the same thing with resistance in the series circuit. This is parallel, so you will be given 3 currents. Add them all up, because 3 paths. This is the beginning of the river before it splits. Then it splits down 3 different paths, and it comes back together. So the value here at the power supply, whatever you're given at the power supply, is the total. That's going to be resistance total. So you add up your 3 paths, you've got current total. You go to current total, current times resistance gives you volts. It's a parallel circuit. So whatever voltage you come up with, they all share that. So now you've got volts and current for everything. You've got 2 values. You can you've got it solved.
Scott, this is kind of a silly question. I know the answer, but could you just give an example of milliamps to amps?
Okay, milliamps. Milli is 3 places. So if I have 2.3 milliamps, I move the decimal 3 places to the left. 1, 2, 3. So it's going to be 0.0023 amps.
Thank you.
2.3. So if it's milliohms, milliwatts, whatever, you move the decimal 3 places to the left, and you get rid of the m. And then you have one of these, and we're gonna do some more of these. And then you have one of these, and that's it. So if you look, we redrew this. Here's our power supply. We come to our first resistor. That one's in series. Everything passes through this. And then this is R5. This is the last resistor before it returns. So these two are series. So these 3 will share the current, all the same current. Just think of it as water flowing in a circle. Everything flows through here, and it splits into two paths, comes back together, just continually loops around. It splits, it comes together, but everything flows through here. So the current is going to be the same in those 3 places. It gave me a current here and a current here. So it only splits in 2 paths. I can add those 2 paths up. I've got the total current, which is the total current, which is my current for R1 and R5. So in that instance, I'll circle up here. I was given resistance total, so I'm going to circle that. I'm given watts for R1. I'm giving amps for R2 and R3. I'm giving watts for R4. And R5 I'm giving ohms. I'll erase that circle so it's not confusing. So what I have is, I have the current for R2 and R3. So these two added together are going to give me this current and that current. Actually, not R4. R4 is going to be the same as the one before. I'm going to have R5s and I'm going to have the total. Maybe, I don't know if this helps you doing the circles, but I'm just trying to show you what I have. This R3 and R4 are going to be the same current. So I'll have all the currents right away.
I just want to make sure I heard this right. So R3 and R2 are going to be cumulative and equal R1?
Yeah, because if it's my river scenario, R1 is up here.
Right.
And it splits. Here is R2, R3, R4, R5.
So R1 and R5 are going to have the same current.
R1 and R5 are going to have the same current.
Okay, because that's like the series.
Yeah. R3 and R4 are going to have the same current too.
Added.
No,
it's the same.
they'll be identical.
Oh.
Whatever flows past R3 flows past R4.
Because they're in series.
They're in series.
Current's the same.
Think of it like a campsite. And you're sitting along a river. You're upstream. The guys downstream are getting the same amount of flow.
R3 and R4 are in series up here.
Yeah, they're in series right here. So my current, whatever is flowing, if you can visualize current or water flowing, splitting, flowing, whatever. If this is a paddle wheel, these two are going to be turning the same speed.
Okay, that makes sense. Thank you.
So all I have to do is that R2 is on the left side, and I can have the current either if I know R3 or R4. Since there are only 2 paths and I know how much is in each of those paths, I just add them together. That tells me how much is coming in and how much is coming out.
I'm sorry, which two did you add together for that?
I'm just taking a cross section
Oh.
here and here. It doesn't even have to be whatever current is
Yeah,
flowing.
because that's its own version, that's its own lane, so
Yeah.
it's gonna be equal to 3 and 4?
3 and 4 will have the same current.
Yeah, okay, so it'll be equal to those.
I don't know any better way.
No,
Somebody's got a better scenario than my
No,
river.
It makes sense, I just got it right now. I promise.
It's not, to me, this is easier than looking at that. But literally, I have one flow, and it splits and comes back together. And if I know what's regardless of how many resistors are in that path, I just need to know how much is going down the left side and how much is going down the right side. And if I know only that, adding them together will give me how much total flow I have.
So R2 and R3 added together is the total current?
Uh-huh.
Okay.
And R3 and R4 are going to have the same current. They gave us R3's current. Maybe a paddle wheel is a good scenario. That paddle wheel is going to turn based on how much flow is going through here. These two are going to be turning the same, identical, because they're on the same leg, the same flow path. So giving me R3's current also gives me R4's current. I can just copy it in the grid. I can copy R3's to R4's. And then adding 2 and 3 together give me R1, R5 in the total. Knowing these two paths give me this and this and that. So right away, I see these two split paths. I just add those together. Now I know this current, so I know this current. They're the same. I add this leg, this path, and this path together. I've got all the rest. So right off the bat, I've got all of my currents. They gave me power for R1, so I've got two values. I've got current and power for R1. For R2, I've only got current. Actually, for R2, I only have current right now. I'm just going by what I circled. R3, I have current only. R4, I have current and I have power because they gave me watts and I got my current from R3. Down to R5, I've got current and resistance because I knew I added to get my current and they gave me resistance. So I can solve everything for R1 and R5 and the total. Knowing, so let's see where I go from there. We'll do one of these. We'll do these rather than me just trying to explain it to you. It'd be easier if we just do them.
What's the bonus question here?
The bonus question was,
If R2 gets
and
open, what is our total?
okay, so if R2 opens, now, once we've done the grid, the resistance isn't going to change, except R2 is going to go away. So I can forget that resistance, and it's a series circuit. So really, all I have to do is erase R2 and add up my resistances and get my new resistance total. Oh, it's how much power? How much power is dissipated? What they're asking is, they're saying dissipated because power is what we're using or dissipating. So that's why power, when we arrange this, whether it's series or series parallel, the power is additive. That's because that's how much we're burning. It's like if I put, my example was if I have 10 100-watt bulbs in here, I'm burning 1,000 watts. It doesn't matter if I put those in series or parallel wiring, they're burning 1,000 watts. They're putting out heat. So that's why I can add them in any direction. That's how much is being used, power. So they're saying how much is being dissipated. It's a lousy way of saying it. They just want to know current watts.
This is the power for R2.
They just want to know total, how much power is dissipated. So they just want to know power, watts, total watts.
So you just subtract.
So you take your total resistance and you can use, your current is going to change because R2 went away. But your voltage is still going to be the same
so
because that's your battery. or whatever your generator's putting out. That's my memory's reminder for break.
The answer for the what?
So what you do, the answer would be, you use the voltage because it won't change and the individual resistors won't change. So you just take away R2, you add up the resistance, and you use your voltage or resistance to get power.
To get a new power, and then you have to take it
From the old power.
away the
No, they just,
power from before with R2.
Yeah,
no,
just to do
well,
it.
they're saying how much is dissipated. What I'm looking for, and what my answer sheet is, what the wattage is. And I may have changed this on the actual test, but all I'm looking for is total power.
If it's additive, can't you just subtract total from R2
Yeah,
from total?
I could. I could literally just subtract R2's power and add them up.